Yeah, all the students. Good morning, students. Can you hear me? Okay, so 7, okay, 9, so you. Morning. So everyone can hear, right? And this is not a mirror image, right? Everything is clear, right? Okay, so yeah, let us start the class. Okay, time is already exactly the 7:30. Okay, so let them to come. Okay, so last time we already discussed about what? That we already discussed about the equivalent or is the effective resistance and all. Okay, so we already discussed before in terms of the series. We already learned. Okay, good morning, everyone. Okay, so about the series. Just we are reminding you before what we have learned. Okay, so in the series connections and all, we already learned that equivalent effective resistance of the RS is what? That is the R1 plus R2 plus R3 plus dot dot dot. That means that whatever the many, okay, whenever we connect any resistance more than 3 or more than 4, then they will come here. Okay, R4, R5, R6 and all, it can come in this way. And also, we already learned about the, you see, for the parallel connections. For the parallel connections, we already know that 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dot dot. Yeah, these things we already learned before. Okay, and today we are going to do some exercise on these parallel and the series connections. Yeah, good mornings. Okay, yeah. So all these things only we are going to learn. And before going that one, last time we already developed one equations, but I didn't explain you about what I call the resistivity and all. Okay, so today let us complete all those kind of the courses. That means, okay, so, okay, 16 member of you are here, so let us start. So before what we already discussed, before we discuss the Ohm's law, okay, so Ohm's law we already learned, okay, and according to the Ohm's law, you know that the resistance of the conductor depend on the what factors, that only, and from there we will develop the equation of the resistivity. All right, so here let us start the class with that one. Yeah, so that one, what factor in which the resistance of a conductor depends. Okay, what are the factor in which, or what are the factor the resistance of a conductor depends? So like this, if it comes in exam, then it can ask the questions in this way also, no problem. Okay, so here we are going to start. Here we already know here the factors are, I don't write here. Okay, number first point of factor. Okay, number first factor is that resistance of the conductor is directly proportional to the length of the conductor. Okay, that means that resistance is, we already given you, but still we have to develop one equation. Okay, so that one I don't show you. Okay, that's why only I'm taking here. Resistance is directly proportional to the length. Directly proportional to the length of the conductor. Therefore, R is directly proportional to the L. where L is the length of the conductor. Okay, where L is the length of the conductor. Okay, so this is the first point. And in the second point here, what will come, that is inversely proportional to the area of the cross section. Okay, that means that the resistance is inversely proportional to the area of the cross section of the wire, or just say the conductor. Okay, area of the cross sections of the conductor. Okay, so here you should not confuse about the area of the cross sections. Okay, so therefore R is inversely proportional. Here will be, it will come like this. Suppose this is a conductor. Suppose this is a conductor, and here, okay, so here on this surface area, the cross sectional area, it will be this one. Then what is the shape of this one? The shape of the metallic conductor, that is what? In the form of cylinder only. Okay, or what about this surface? It is in the shape of the, what I call, the circle only. Okay, and we know that the area of the circle is pi r square, where r is the resistance. Okay, if the diameter is given, then we have to know, we already know the equations here. There is the diameter is equal to twice time of radius. Therefore, r is equal to, what is here? D by 2. Okay, radius is coming here, the diameter by 2. So these equations also you have to keep in mind. Yeah, so this is all about this one. Okay, and still we have to write more here. What is that? We know that the factors are, you say, not only this one, the resistance is also directly proportional to the temperature. Okay, when the temperature raised, then the resistance also raised only. Yeah, so you make it, this is the first equation, this is the second equation. Yeah, first and the second equation, and from these two equations only we are going to develop about that one. Okay, that is the resistance is directly proportional to the L by A, like that. Okay, and their resistivity constant is going to come. All right, so let me complete this one, 1, 2 factor, and the number 3 are also there. Okay. Number 3 factor is that is the temperature. Resistance is directly proportional to the temperature. Therefore, R is just, you can say, T. Okay, T for temperature only. Okay, so here you already know that at constant temperature, resistance value of any conductor is constant only. Okay, and with raise in temperature, the resistance also surely will raise. And when the temperature is down, okay, slow, I mean that the temperature is down, then resistance will also surely will down. Okay, so this point you have to keep in mind. Yeah, so let us come to our point. From this equation you have to keep in mind, and this equation 2 you have to keep in mind by combining, okay, equation 1 and 2. Now 1 and 2 we get here what will come, that is the R is directly proportional to L, and you know that is the L. Okay, I will make it a little bit longer here. Okay, no problem. So that is the L into 1 by A. So I think you know this one, that it comes to here L by A only. Okay, it comes to here L by A. Yeah, and then here, yeah, in the directly proportions here, if it is equal to 1, the direct proportion value equal to 1, then the same time that resistance also surely will be 1. Suppose the length is, because the direct proportion means that with increase in the another factor, suppose the resistance is increased by 1, then surely the length, or just say the length is increased by twice, then the resistance also will increase by twice. That's only, okay? And about inverse proportion, just opposite only. Okay, in one factor, suppose the area is increased, then here the area of the cross sections of this wire is increased, then the resistance value surely will get down. Got the point? Yeah, area is increased, then the resistance value surely will get down. That's point only. And if it is less, then the resistance value will high. So that is inversely proportions. Okay, yeah. And then here, we are going to come here. We got R is okay. To make confusion here, okay. Yeah, let me write down here. Otherwise, you may get confused. Therefore, here it comes to R is directly proportional to L by A. Then from here, a constant resistivity constant is going to come. Therefore, R is equal to here. It will come. It's just like phi only, okay? So there is the resistivity constant, okay? And it comes to L by A. Yeah. This is the resistivity constant, okay? And here it comes together. Here what we can write. Suppose here we can find out the resistivity value also, okay? Let me write first. Where this is rho, okay? Rho is the what? In Greek word, it is called rho, okay? Is resistivity constant. Yes. This is the resistivity constant. Sure. We have to know this one. Yeah. Okay, so from here, we can find out the value of, that means the equations of this resistivity. Then how? But that ones I will give you, okay, so here itself you can give. Okay, then you must know that what define resistivity, again, here is going to come. This is also the properties of the conductors. Property of the any conductors, okay, that is a good conductor, it should be right. Property of the conductor which is E-A-S-E, that means that which make it easier the current to flow. What the resistance do? Resistance oppose करता है. Resistance always time oppose the flow of the current. बोलता है मत जाओ बोलकर, right? But in terms of the resistivity, which make it ease, that means that हाँ जल्दी भागने के जाने के लिए कोशिश कर देते हैं. Okay, so this points we have to know. Yeah. Okay, fine. So again, now we are going to come resistivity. Okay, the definitions is going to come now here. Okay, I will have this second, this third point about temperature. Okay, so I explained to you now that the temperature will increase in temperature, then the resistance will also increase. Yeah, this point you have to keep in mind, but there's no use in the equations at all. Then here we come to know that is the resistivity. Then here it will come. It is the property of the conductor okay, with ease, or just we can say just make it easier to flow, okay, or just allow to flow. The flow of the current. Okay, this is the property of the conductor. which is the flow of the current. Okay, just simply it's called as the resistivity. And then these equations, okay, we're going to develop. Therefore, we know that resistance is, we already know here, if we multiply, this is like P ohm, okay, L divided by A. As we know, there is 1. That means we take there is 1 down this 1. Okay, then here by cross multiply, what will come here? Rho L is equal to R. Okay, resistance and the area, or this is the cross section area, will multiply here. And then here, what will come? Therefore, what we can do here is equal to RA by L. So this point we have to know. Okay, yeah. So at this point we have to keep in mind that the resistivity values and all, right? So you must know that these equations can be developed from the Ohm's law. Okay, so from the Ohm's law only develop these equations. Yeah, we have to keep in mind this point. Yeah, and you must know that here the resistivity value of the what we call the metals, they are less. The resistivity value, if the resistivity value is less, then here their conductions, the conductivity will be fast or more, we can say. And the resistivity value is high, then their conductivity will not be there. Just like say the paper and all, okay, or a paper, or you say the diamonds or wood and all, okay, they have their resistivity range from the 10 to power what they call the 10 to power 8 to the 10 to power 11, like that. And then of the, just like say the metals like the copper and all, that is 1.62 into 10 to the power minus 8. All this value will be given, okay, it will keep in the questions if we calculate the questions, or if not, then here you see 1 2 3 4, there are 1 2 3 4, 4 factors are here, and for factors here, if we know out of 4, if we know 3, then one can find out, just keep in mind. Okay, and if instead of area, sometimes they can give the, because I already told you that is the cross-sectional area, we will find the area of the circle, that is pi r square. Instead of this radius, they can give the what? That is the diameter. When it gives the diameter, at a time, what we will do, that we'll use this formula. You know, diameter is equal to twice times of radius. Then r is equal to d by 2. Then here, instead of radius, diameter is given then in the cross-sectional area, pi into d by 2 will be there, and 2 sometimes comes down. So that's one. Okay, so all this calculations part and all we'll do in the next class only. Okay, so but just you clear about all these things. Okay, so this is all about the what we call the resistivity. Okay, then here last time we already discussed about the resistance of the conductors, which are connected in the series, also in the parallel, that we already learned. And today I want to start a class with that is the heating effect of the electric current. Heating effect of electric currents. Yeah, and here you know some of the heat that I told you, resistance, they used to oppose the flow of the current, and they convert this current into the heat energy, just like this the bulb or a fan or any electrical appliances. When it works, okay, through the current, then what happened, due to its resistance, it developed heat. But what we are going to learn now is that heating effect of electric current, that is the due to the resistance, it opposes the flow of the current, and it converted it into the heat energy. Then how we can use that loss energy, or just say that how we can use this energy into the usable form, that's only we are going to learn today. Yeah, so that's point only. Okay, we are going to learn today, and with that one we will come to know the many appliances, just like the electric heater, room heater, okay, and even for cooking, and also we are using all those, right? So for them also we will come to know. That means the applications of the heating effect of electric current, like that. Okay, you know the heat is the form of energy, we already know, right? So yeah, let's go now. Yeah. that equations we have to develop. The equations of the heat. Here it comes to heating effects of electric current. Okay, heating effect of electric current. But this heating effect is going to be produced by the resistance of the conductor. Okay, and here we use those kinds of the elements, or you say the elements which have the highest resistance value, just like nichrome wire. Nichrome wire, okay, nichrome wire have the highest resistance value. That's why it used to oppose the flow of the current, and it convert the electrical energy into heat energy. That's why we use in the room heater, okay, immersion heater, or in the electric rice cooker, and also we use such kinds of the metals, or this is the element. Yeah, that's fine. Yeah, heating effect of electric currents. So we already know that is the heat. The first of all, just we have to know some terms like you see the heat. Heat, what is heat? We can ask. Okay, just simply it is the form of the energy. In the lower standards, in the previous in the years, you already learned about the heat. That means the energy can be transformed from one form to another. We already know. Energy can convert or can transform from one form to another forms. Okay, just like the electric energy can be converted into the sound energy that we use in our microphones. We can convert the heat energy, electrical energy into the heat energy. That's only we are going to learn here. Okay, so all these things we have to know. And electrical energy can be converted into the mechanical energy that work in our fan and all. Yeah. So here the heat is the form of energy. Okay, and this heat develop that how much of the heat will be produced, or how much of the heat will be produced by the conductor. We are going to develop the equations. And don't get confused again. The heat produced here will be what? The heat produced will be the work done. It should be equal to the work done. कितना काम करता है by this bulb, by that heater. That will be the heat. Okay, how much it is produced? Then according to their only we are using, right? That means the how much of the work is done by that conductor will find. Yeah, so without wasting the time here, let's develop that equation. Okay, that equation will develop from where? We'll develop that equations from the what I call the potential difference. Okay, so here we know that. Okay, or let's say the derivations of the heating effect of electric current. If I give the, let's say, better to write derivations of the equations of heating effect of electric current. Yeah, derivations of the equations of the heating effect of electric current. So here we are going to learn here. It will start from the potential difference that we already learned. Okay, or just is from the current also we can start, no problem. All right. So okay, let's start from the currents. Okay, we know that what we know that is current in a conductor is charged by time, right? That is the current, or you say the current is how much of the charge is flow in the conductor per unit time. That's only we defined before, right? So here it comes to I is equal to Q by T. Q you can write the small letter also, no problem. So it comes to Q by T. And from here we develop the equations what? Therefore here it comes to Q is equal to IT. That question we developed before. That is from the current. Just you can take it as the question number 1. Okay, and the last time in the previous classes, some of you are asking about the sir, this is the equations of the heating effect. Yeah, so from here only going to comes that equation of the heating effect also. No. Then again, okay, I'll just say simply and potential difference. Okay, so potential difference, or you say simply as we will write, okay, potential what we know potential difference is not visible. Yeah, potential difference is equal to it is the amount of the work done. It is the work done, okay, for moving a unit charge. That is the work done by charge. Yeah. So potential difference across the end of the conductor is the amount of the work done per unit charge. Okay, so this is the question of the potential difference. And from these equations, combining with this equation number 1 only, we are going to develop that equation. Okay, yeah, so I'll wrap this one, all right? Okay, so we are deriving the equation of the heating effect of the current. Yeah, and then here, the potential difference is generally denoted by V and work done by W, charge by Q. Charge by Q. And then here again, by cross multiply, here we take in the denominator there is 1. Then by cross multiply, here it comes to work done. That is equal to V into Q. Okay, VQ, and then here again work done equal to V into Q is equal to IT, as we know in the equation 1. That is the IT. Then here it comes to, instead of just say yes, you can remove into, no problem. So here it comes to work done is equal to VIT. That is the equation number 2. We can write down, no problem. Okay, so this is the equation number 2, or just say from here also how much of the work is done by the conductor we can find out. Okay, yeah, these points we already know. And here again we have to know that here work done is equal to the what? Work done is equal to the heat produced. Okay, work done by that conductor is equal to the heat produced in the conductor. Okay, that's why here instead of work done here what we can write by the heat. And the heats can be denoted by the capital H. All right, so therefore what happens, we know that work done is equal to the heat produced. Therefore, instead of W, what we can write, H is equal to VIT. Yeah. So this is the equations of what? The heat produced by the conductor. Okay. So here, not only this one. If we use the Ohm's law, Ohm's law here, from this equation we can develop other equations also. That only we are going to do here. I think so all of you are not present here. Only 16 of you are here, and I already shared the links beforehand. Okay, before the 1 day before, I already shared the links, and the others are not yet turns up. Why? Okay, and at the end of the class, you have to keep your name there in the WhatsApp group also, all the students. Okay, and even here also you can send your name. Okay, I can check those who are giving the message and all. You must give your name also. Okay, and I'll give reports to the authority also. All right. Okay, so please drop your name when our session is over. All right. Yeah. Yeah. So heat produced by the conductor is equal to VIT. We already know. And then now what we are going to do here. Okay, fine. So at the end of the class you can give note now also. Okay, fine. Yeah. Then here what we have to do, okay, from Ohm's law. From Ohm's law. Ohm's law says that Ohm's law here we already know that is a V is equal to Ri or NATO V is equal to IR. Right? So here from here what we can come, this V value that V is equal to Ri or not IR, right? So this value we will substitute here in this equation. Okay, you can make equation number 2, no problem here. Okay, we are going to put that V is equal to Ri or IR in this equation number 2. All right, then here, therefore, here the equations of the heating effect or heat produced by the conductor, it will come here instead of V. Don't get confused. Okay, we are going to substitute the value of V in the equation number 2. Here is VIT, right? Instead of V, we will write Ri, R into I only. Okay, don't get confused. Ri into IT. Then what will come here? That is you can write first I, no problem. I square RT. That means the heat produced, it's also equal to what? I square RT. This is the first equation of the heat produced, and this is the second equations. Okay, this is the second equations of the heat produced, and again here going to comes the another one. Okay, so because here we know that from the Ohm's law itself, okay, from the Ohm's law itself, what we know, V is equal to Ri only. Therefore, what it will come here, that we can find out equation of I. I is equal to what will come? V by R. Yes. Yes, we can write the since. Okay, so this since you can write down here. And then from here, instead of I, we are going to substitute the value V by R. Okay, so these questions we're going to come now. Yes. Okay, at least we will try to complete, we will try to finish this chapter. Okay, so today will be the, you see, the day 4 class only. Okay, and all the theoretical part will finish, and in the next day, in the day 5, we will finish all the question answer. Okay, that is the numerical problems and all, and many calculations by giving the figures of the resistance and all, either in the series or parallel connection. We will do that one. All right, yeah. So this is is equal to I square RT. Then what will come here? X is equal to, that is, we know that I is equal to V by R. This is I square only. Then instead of I, we can write V by R holding square RT. Okay, so V by R holding square RT here. Then here, what we'll do, it comes to V square by R square into R into T. R square means what? R square means that twice. That means that R square means that R into R. Don't get confused. Some of the students used to do 5 square is how much? Some students used to say that 5 square is 5 into 2. That comes to 10. That is wrong. Okay, so still in your standard also student get confused. Don't get confused. 5 square or any power, that means that that number, according to that number, will multiply. That means that this is wrong. Okay, then what is the correct? 5 square means that 5 into 5. That means that 5 is multiplied twice times. Like that here, R square means that R is multiplied twice times. All right, then here 5 is 25, not 10. Okay, so at this point, please don't get confused. Okay, then now here are going to come, the first equation is already here, and the second equation also for finding the heat energy also already here. And then here we are going to write here the X is equal to V square by to make it easier, let it be longer, no problem. But the main thing is that you understand. That is more important, right? Into R into T. This R, because this is in the numerator and this is denominator, you can cancel. Then at last, here it comes that the equations of the heating effect of the current is also V squared by RT. One single R and this one R, or it cancel, then here it comes. Okay, here it comes. X is also equal to, that is the V squared by RT. Here you have to know that T is in the numerator only, okay, not in the denominator. So here, like this, we find out the three equations, 1, 2, and 3. Three equations of the heating effect of the electric current. Okay, so any equations, I mean that in any equations, according to the value given in the equation, we can find out. Okay, we can find out the value of the heat. That means the how much of the heat is produced by this conductor. Okay, so like that we can find out. Okay, first of all, let us sum up along with its applications and also electrical power and all. Okay, I just mentioned you. We will find out its what I call the numerical problems in the next class. I told you, right? Okay, so a little bit down. Yes. Wait. Okay, so now now it's okay, fine. Yeah, so like this we can find it. Okay, can I wrap this one? Then here we'll go for the applications of this heating effect of the electric current. Okay, so don't get confused. X is equal to BIT, I squared RT, and V squared by RT. So these are the three equations of the heating effect of electric currents. Okay, so like this here at conclusions. Okay, just I will make a conclusion here. Okay. Hence, the equation of heating effect of electric currents are, okay, hence the heating effect of the electric current are, what is that? We already know that is equal to VIT. We know, right? And the second one is that is also equal to, we can write, no problem. Okay, I square RT, and what is that? V squared by RT. All right, so like this we can derive. Okay, so now let's come to the application part. Okay, just keep in mind all these equations and from where it developed. If you have the knowledge about the current that we already discussed before, and also if you have the knowledge about the potential difference that we already discussed, and also if you have the knowledge about the Ohm's law and the factor in which the resistance of the conductor depend, then we can derive this heating effect of electric current equation very easily. So you must try to do the revisions again and again. Okay, and according to that one only we are going to do. All right, so now here what we are going to come here, we are going to come to the applications. Okay, so applications of heating effect of electric currents. Applications. What are the applications of the heating effect of electric currents? So many. So we use the irons. Okay. So we use the iron. Then here that is also an application. We use the immersion heater. We use the rice cooker and also. Okay. Many others are there. Let us write down some of the points. Okay. Number one, the first point is say electric heater, electric iron, and water heater. Okay, yes, together. Electric heater, iron, and immersion heater is just to boil the water we use, right? That one, okay? Electric heater, iron, and the immersion. All right. So here about the, or just say the water heater also we can say simply, okay? Immersion heater work on the principle of, okay, on principle of the what called heating effect, okay? Yeah, or just say principle को छोड़ने से भी हो जाएगा, okay? Work on heating effect of electrical, that's all. Work on the heating effect of electric currents. Yeah, this is the first point. Okay, in the second point, just like electric bulb and all, okay? So electric bulb, okay, when electric current pass through the bulb, then the filaments of the bulb, it gives light. Just now it is the LED and the CFC, fluorescence tubes and all we use, okay? Before, in the olden time here, we use a bulb. Right. So like these kinds of the bulbs we use, right? So here, this is the tungsten wire. This is the shape itself. It makes the shape W shape. Why W? This metal's name is called as tungsten. Tungsten, okay? And this tungsten its symbol is W. Why? Because it comes from the Greek and name or Greek and Latin name, that is the old forms. Okay, from the W it starts. Okay, that's why it gives the W. So its shape is also making just like a W only. Okay, so that is another case. Okay, so in the second point here, we can write down number 2, electric bulb glow. Okay, when electric bulb glow, when electric current, pass through the coil of the wire. Okay, pass through the filaments. We call it the filaments. Okay, filaments. What? The filaments of the bulb. Okay, we can say. Okay, when we pass the electric current through the filaments of the what I call the bulb, at the time what happened, the filament, these tungsten wire, they get heated. Okay, it get heated and it produced by producing the very bright lighted. And you must know that this tungsten wire, its boiling point and the melting point is very high. That's why at a very high temperature also it does not melt. This point, okay, it has the high melting and the boiling point. So this tungsten wire is used as filament in the bulb. Why not other? Why copper? We don't use copper. Why we don't use aluminum? Because their melting point is low. The melting point of the copper wire, or you say aluminum wire or some others wire, their melting point is low. That's why we don't use. Instead, that we use a tungsten wire, which have the high melting and boiling point. So that is the reason behind the point why we don't use copper wire and all. Yeah. So this is the second point. First point, we know that electric heater, irons, immersion heater work on the principle of the heating effect of electric current, and electric bulb glow when the electric current passes through the filaments of the what we call the bulb. So this is the second one. And also one of the most important, and it is very related with our what we call this chapter, is the fuse wire. Fuse wire, okay. So in every appliances in our home, even your main supply, that is the electric supply from the pole that we get with the 2 wire, and then we connect it to your home. Okay, in the electric switch board will be there. And here again, there is the fuse wire. This fuse wire, what happened? We use the fuse wire by having a low melting points, what I call melting points, alloy and all. Why? Because when the short circuit happen, just say the short circuit happened when the what happened when the positive terminal and negative terminal they join together, or due to the leakage somewhere. Okay, so due to that short circuit, high voltage currents used to flow in our home circuit, and then our bulb, our fan, or the television set, they work on the some voltage. Let's say the 232, 240, or 50 volt in between there one only. And during the short circuit, very high volt overloaded current used to flow. When this overload current flow, if there is no fuse wire, then when you are using your television set, then it will go through that television set, and all the appliances, all the parts there in television, it will destroy. That means it will spoil. Like that, your TV is damaged or your fridge is damaged. Okay, so to prevent from this, we use fuse wire. Fuse wire are used. The short circuit itself can happen inside your home also, no problem. But to prevent from this overloaded current here, every appliances, mainly nowadays, okay, most of the appliances that we use, they have their own fuse wire inside. They have their own fuse wire inside. That when the short circuit is, when short circuit current is happen there in your home itself, then it will prevent from that. All right. Okay, number third point of the applications of this heating effect of electric current is that electric fuse, we can say, okay, no problem. Or just say the fuse wire, okay, electric fuse in the electric current, okay. Electric fuse in the electric circuits melt when large current, or also you can say the high volt current also, no problem, okay, flow in the circuits. Yeah, at the end of the class, of the chapter, again, fuse where we're going to learn. So I will not I will not explain you more about this one. Just you understand that this fuse wire prevents from the possible damage caused by the short circuits and all. Yeah, this point you have to know. Okay, so these are the some of the applications, okay, of this one heating effect of the electric currents. Yeah, then let us come to know about let us come to the point that is the electric energy. Okay, we are going to come to electric energy. How much of the, okay, this is Aditya, okay, fine. Okay, so Aditya, and also I already given you before, and the timing of the class and all, must try to join the class in time next time, okay? Yeah, so this is all about the applications of the heating effect of electric current. Okay, now here are going to come the electric energy. Okay, so electrical energy and also here electrical power and all we're going to come. Okay, so here electrical energy, okay, it is the work done by a source of the electricity. Okay, just like this, it will be the same as that of the, just say, the electrical power, also it will be similar only. Yeah, certain. Okay, fine. Okay. We will come to the here electric energy. After that only we are going to come power. Okay, electrical power. Okay, so that also we will learn here. Okay, I'll wrap this one applications. So here will come the work done by what? Okay, the work will be done by the source of the electricity only, okay? The work done by the source of electricity. Okay, so here we can write like this also, no problem. Who is that? Can we come? Okay, so work done by the source, okay, source of the electricity to maintain the current. Okay, to maintain the current in an electrical circuit. In an electrical circuit is called or is known as what? Electrical energy. Yeah. So the work done by the source of electricity to maintain the current in an electrical circuit is called as the electrical energy. Okay, so electrical energy, from that only here we used to calculate or and we used to give the amounts of the using this electrical energy. Okay, the electrical energy here, how much of the electrical energy is used by your home or by a bulb in a day, and how many hours or how many minutes we use, it depends. Okay, so according to that one we can calculate the amounts, how much the amount you have to pay monthly and all. Okay, so like that we can find out. Okay, means like we are going to learn here. Okay, and this electrical energy here, it maintain all those, means that is the work done by the tube. Don't get confused by the work done. ये bulb ने क्या काम करेगा, ये fan ने क्या काम करेगा? They will work on the you see, to produce the light. They will work to give the mechanical energy and all. Okay, yeah. So these points we have to keep in mind. All right. So here we can discuss about all these things. We already know that the charge is equal to U is equal to IT and all. Okay. Yeah. So we are going to continue the class again. Rebecca is there. Okay. Yeah. So then we are going to come here. That is the work done के unit तो हम लोग पहला समझ गया. Okay. From here we come. That is, I am going to produce an equations of the electrical energy also here. Okay. Then here we already know that here V is equal to IT. Okay. So okay, just go for the another equation. Just say another equation. This will be confusion again. Okay. We know that work done is what? Work done के unit क्या था? Sorry. What we find out, that equation is the VIT. VIT we already know. And here you must know that here the work done is equal to the electrical energy consumed. Work done is equal to the electrical energy consumed. Okay, so this point also you have to keep in mind. Okay, it is the also equal to the electrical energy consumed in the circuit. Then what will come? Therefore, what will take? Okay, therefore, here will comes that W is also equal to E. Electrical energy can be substituted by the capital letter E. then E will be here. That is, in this equation, we are going to substitute. Okay, therefore here, instead of W, that is W is equal to E only now. Then here we can write either W or E as equal to, that is VIT. Okay, so this equation also we have to know. Okay, so E is equal to VIT, or no problem. Because here we make it work is the amount of that is the electrical energy consumed. That it is equal to VIT. So this is all about the electrical energy. Okay, thus you have to see this E here. Okay, this equation too we already come to know before also. Okay, okay. Then after this one only here, what is the time? Okay, 7:30 you have the class again, right? Okay, so this is all about this one, and it is not possible to complete all these things, okay? Because here we have to find out some of the, I mean that some political power and the commercial unit, okay? And I will explain now only, okay? So just to wait some of the time. Okay, and before, I just forgot to keep the one point about this one. Please, you have this space, please note down the resistance. Okay, it's SI units. Okay, resistance का SI units क्या था? That is ohms. Okay, it is denoted by this omega. Okay, this is the ohms, and also resistivity is there, right? What you give resistivity. Okay, for the resistivity, what will come? That is the ohms per meter. Okay. Or you can write ohms minus 1. Okay, many times students get confused. Ohms minus 1, that is the ohms per what do you call per meter minus, sorry, this one. Okay, minus like this also we can write, no problem. Okay, yeah, so just try to understand this point. Okay, after this one here, what we are going to study in the next class, we are going to learn about the electrical power. Okay, that is the electrical power is the amount of the electrical energy consumed by the conductor. Okay, the amount of the electrical energy consumed by the conductor in the circuits. Okay, and after that one here we will learn about that is the power to, as you know, work done by that is the amount of the work done unit time. Okay, so P is equal to W by T, it will come the equation. Yeah, from there again, we are going to develop the how much of the electrical energy consumed, so that we already know here, and the power. We will find out for the power also. Okay, after learning that one here, we will learn about the commercial units of the electrical power. The commercial unit of the electrical power is the kilowatt hour. Kilowatt hour. Okay, in India here, what happens per kilowatt? Per kilowatt, according to the where it is used, commercial purpose and in the industrial purpose, they are different. Okay, for the household and all, the per unit. Okay, per unit means the per 1 kilowatt hour. 1 kilowatt hour. Okay, there it costs rupees, say about rupees 9. Rupees 4. 4 rupees. Okay, per kilowatt hour. Okay, and in that of the industry and all, they will use some more amounts, just like rupees 8, just like double that of the amounts. Yeah, so okay, all the students, and thanks for joining the class. Yeah, okay, so little boy and all. Okay, so don't forget just to drop your name and all. Okay, so here, and also yes, you can do one thing. You can drop down there in our group also. Okay, no problem, that will be very fine also. Okay, yes, I have to. Okay, so all your chat and all these things will be recorded with me only. So don't forget. Yes, Menung Zeli, Chatan Niras, Aditya, Samrat. Okay, anyone else here? Sumit Kumar, Rebecca, Ifran, Minam Sinu, Kenny Kamdak. Kenny Kamdak is the new student, I think so. John Proik, okay. Okay, Arun Tanti video is not coming, but for everyone it is coming, I think so. Network is good only. Samrat, Jasni, Raji, Savannah, okay, Tunjo, Satan, Aditya, okay, Niras Datta, okay, all those. Abiras Sango is here. Samrat Chat, okay, okay, yeah. Kaminu, okay, and okay, so like that. Okay, all of you, thanks for joining the class. And in the next day, I think from the next week, the classes may conduct in our school app itself also. Okay, so through the online support and all. Okay, if not, if we get within this week, then we'll continue the class with this only. Okay. Okay, then thanks for joining the class, and hope you stay nicely and free from the COVID and all. Okay. So stay nicely at home and always be safe and stay safe. Okay, so this is just a message to be safe from this COVID-19. Okay, thanks for joining the class, all of you. Thank you. Bye-bye. Okay.